This is section 2-4, and in this section we are going to explore compound interest. Now we have a quote to start off with, and this quote says, "In the old days, a man who saved money was a miser. Nowadays, he's a wonder." Well, if you think about that, saving has become somewhat non-existent among today's society. So anybody who saves, indeed, must be considered a wonder to some degree, all right? So I think that's what they're driving at here. The objectives of this unit are going to be to explain the concept of getting interest on your interest. In other words, introducing this whole idea of compound interest. All right, let's look at some definitions here. First of these is obviously compound interest, all right? And compound interest, this is money earned on the money deposited plus previous interest. So in other words, you're earning interest on interest as well as earning interest on the amount you deposited. All right, the next is annual compounding. This is where interest is compounded once a year, all right? The next, semi-annual compounding. This is the same thing, except interest is now compounded twice per year or every 6 months. And obviously, as we keep going here, we've got quarterly compounding. This is where interest is compounded 4 times a year or every 3 months. And then lastly on our list here is daily compounding. This is where interest is compounded every day, or in other words, 365 times a year, or during leap years, as 2020 was, 366 times a year. And lastly is the term crediting. This is the act of adding interest or a deposit to an account by a bank. So basically, they're adding it to your statement, if you will. So let's look at an example here. How much interest would $1,000 earn in 1 year at a rate of 2%, compounded annually, and what would be the new balance? All right, so let's look how we're going to calculate this. We're going to start off and use our formula that we're familiar with, the simple interest formula. I is equal to PRT. I is simply the interest, okay, that we're looking at, that we're trying to calculate. P is the principal. R is the interest rate as a decimal. And then T is the time. In this case, it's 1 year. So if I plug all those values in, I come out with an interest after 1 year of $20. So what's the new balance going to be? The new balance would be the original balance plus the interest, or in other words, it comes out to be $1,020, where interest is compounded annually. So let's look at another example. In this case, Maria deposits $1,000 in a savings account that pays 2% interest, but now we're compounded semi-annually, all right? And we want to know what is her balance after 1 year. All right, again, we're going to use the same formula we used before. I equals PRT. $1,000 is the principal, okay? 0.02 is the interest rate. But now the time is not 1, it's 0.5 because we're talking semi-annually. That's twice a year. So that means after 6 months, she's going to have $10 interest. Her balance after 6 months is going to be her $1,000 plus her $10, or it's going to be $1,010, all right? Now, that's not what they asked, though. They asked, well, what's the balance after 1 year? So let's see what happens for the last 6 months of the year. So we have to calculate, again, for the last 6 months, but now her principal is no longer $1,000 as it was before. Her principal now is $1,010. But everything else is the same. The interest rate is still the same, and the time is still the same. So therefore, now for the second 6 months, she earns interest of $10.10. So therefore, her balance after 1 year is going to be her balance after 6 months, which was the $1,010, plus this new interest of $10.10. So her balance now after 1 year is going to be $1,020.10. Now, notice, how does this compare with the result that we had from the previous example? It's very close, but she's made more money. Granted, it's not a lot of money. It's only 10 cents more. But by having the same interest, but having it compounded semi-annually rather than annually, she's made more money. All right, so let's look at another example. How much interest? Again, we're talking $1,000 principal earned in 3 months at an interest rate of 2% compounded quarterly. What is the balance after 3 months? Again, we start off with our same exact formula that we've been using the whole time here. Same principal, 1,000. Same interest rate, 0.02. But now, we're not talking a year. We're not talking a half a year. We're talking a quarter of a year because this is compounded quarterly. So T now is 0.25. So therefore, our interest comes out to be $5, or our balance after 3 months is $1,005. And we could calculate this for each of the months and see how much it would be after a year as well. All right, now let's take it another step further. How much interest does our $1,000 earn in 1 day, okay? In 1 day at an interest rate of 2% compounded daily. What is the balance after a day? Again, we're going to use our same exact formula, I equals PRT. Principal still 1,000. Interest rate is still 0.02. Now the time is 1 day, so it's 1 over 365. And if we multiply that out in 1 day, you earn 5 cents interest. So the balance after 1 day becomes $1,000.05. It's not a lot of money, but you're learning that every single day. All right, let's look at one last example here. Jennifer has a bank account that compounds interest daily at a rate of 1.2%. On July 11th, the principal is $1,234.98. She withdraws $200 for a car repair. She receives a $34 check from her health insurance company and deposits it. And on July 12th, she deposits her $345.77 paycheck. What is her balance at the end of the day on July 12th? All right, so let's take a look at what we're doing here. So we're starting off on the 11th, all right? And if I get my marker picked correctly. So we're starting off on the 11th, all right? And that's where she has her principal of $1,234.98. She deposits her health insurance check. She does a $200 withdrawal. All right, so let's take a look at what's happening here. On the 11th, she starts off with an opening balance of 1,234.98, okay? She deposits her check for 34. She withdraws 200. She has a new principal. Her new principal is $1,068.98. We use the I equals PRT formula to calculate her interest for 1 day. For her interest for 1 day is 4 cents. So her ending balance on the end of the day in the 11th is $1,069.02. All right, so we take this $1,069.02. That's her starting balance or opening balance on the 12th. Now to that, she added her paycheck of $345.77. She had no withdrawals that day. So now she has a principal of $1,414.79. Now this is what she's going to calculate her interest for the second day. Again, using the formula I equals PRT. Now her interest for the second day comes out to be 5 cents. Whoa. And we add that to her principal, and at the end of the July 12th, her new balance is $1,414.84.